screen.
Yep.
So the topic of today's webinar is going to be faster time to insights using automated visualization and machine learning. This has been an interesting space in the last couple of years. I started working on automated machine learning about 4 years ago, and I, had a lot of modules that I had developed over time that I then decided when I came into my current organization to open source. And my employer was very supportive. And so about July of last year, I decided to open source two libraries that I've been working on for some time. One was for automated visualization, the other was for AutoViML. Hopefully we'll get to know more today. First, you all have heard of this question, which is from your frustrated CIO or manager saying, why is my data science teams, taking so long to complete a simple project? And this is a common refrain. And the answers I've heard are machine learning teams are still struggling because ML has a lot of inflexible frameworks. They don't work together very well. And whatever you see in a machine learning tool, you're not able to reproduce. And so people find that to be very difficult when they cannot reproduce what they are seeing in a tool. And we're going to see why we are going to overcome some of that. And next, we are also having collaboration issues and software tools that are not very mature. So these are some of the answers we've heard. We've always had, dirty data. That was, always a problem. We've always had very difficult, large data sets, complicated data sets, incomplete data sets, all different kinds of problems. But these are some of the, problems related to the tool itself. I'm just going to look at the chat board to see if there are any questions. So the sound is pretty low, it says. So I don't know where to increase the sound. Any ideas? Let me see if I can increase the microphone access. I don't want to.
Yeah, I think your sound is okay, and I'm not sure. Maybe some of them maybe hear some low. And when we use, maybe you can like a little bit closer to your computer, to your laptop. That usually helps.
So that maybe because it's not. Hopefully this is now better. The sound volume is better now. All right, so that's good. We are, I'm just going to keep the chat board open, so if any of you find it annoying, we'll use that for answering questions. One of the ways in which we can make a data scientist more productive is to have faster visualization. If we were to get to the data and be able to visualize it very quickly, a lot of us would be able to deliver insights much faster. Second, if we were to have a magic tool that we could wave at our data, which might have hundreds of variables, and it was able to select only the best features, then all of us would be very, very good data scientists. Number third is model selection or automatic model selection. If we were to have a tool that would go through the hundreds of models that are available, select the best models, and tune it for us, that would be even better. And finally, if we could just have a one-click serving, a pipeline where we just click the model and the goes into production, along with the other things that, like I said, visualization, feature selection, model tuning, that could be even better. So these are some of the ways in which we can imagine data scientists being more productive if we had access to those. However, what we are seeing is that current tools are very limited because one, they're proprietary and expensive. If you were to buy into some of the automated tools out in the market, you have some excellent tools, but you also have the feature that you'll be locked into their path. Second, they are somewhat black boxes. Not every AutoViML tool is very open. So you cannot quite understand what exactly it's trying to do. And last, there is very little reproducibility out of the tool. Suppose you were to take the downloaded model and you were to run it on your own system, that'd be great. But what if you were to try to reproduce the results of the model or the black box? Usually you don't get pretty good the same results that you're seeing. Now, in order to overcome some or most of these challenges, I decided to come up with a simpler approach to AutoML. In this particular case, AutoML was designed so that you could actually build multiple machine learning models fast, but they're also interpretable, and which means that you will be able to interpret the results that you're getting. The models will be showing you the steps that they were taking as they went through to build you a model. And the first one is called AutoViML, where it stands for Variant Interpretable Machine Learning. And then AutoViz, which stands for Automatic Visualization. Now, where do these fit in, right? What is AutoViz and what is AutoML? That's the next question. These are both open source tools for a faster time to insights. They're simple, easy to invoke with a single line of code. They're flexible, suited to any kind of structured data without any data prep required. Incremental, you can incrementally build your model. Many of us as data scientists, we want to build a model that would be, able to take us from the simplest model to the most complicated one, step by step, because that's how we build our models. We don't go straight to XGBoost, or we don't go to Light GPM in our first model, or we don't use even all the features in the data set. We try to use a limited feature set, and we try to use a linear model, and then we go from there to a much larger feature set and so on. Experimental. We also like, as data scientists, to compare multiple visualization methods and models step by step. We don't like to go all in. And we also want to be able to get some explanation of the steps being taken so that we can actually explain to some other folks how the model was able to get its results. And finally, we don't want any black boxes. We want something that's reproducible, along with some model pipelines and input outputs. It tells us exactly what it's doing. And hopefully, if we can make it open source, we can get contributions from other community, as we are seeing here. So I built AutoViz and AutoViML to make my own life easier, and I hope it will do the same for you. So what are the two parts of the machine learning process that AutoViML and AutoViz kind of address? What are the two problems? The main problem that AutoViz addresses is an EDA, or exploratory data analysis. And the main pain point that AutoViML addresses is in the area of cleaning, integration, and feature reduction and transformation in the data prep steps. It doesn't do much of feature engineering, but it does limited amount of feature engineering. And then it splits the data automatically, trains on the training data, and then selects the right models, depending on what you tell it to choose. And then it will test it on a test data that's just split from the original data set, and it will provide you an evaluation. What it does not do is to put it into production, nor does it build a pipeline to enable you to put this into production. That is something you will have to write your own code. But since the steps are very clear, how it builds a model, this is a very simple process for you to write new code that would take data, new data, and go through the same steps that AutoViML is doing to be able for you to build your pipeline yourself. Usually it takes you a few minutes to a few hours to build your own pipeline based on what you see from AutoViML. And since AutoViML is like an open box, you can actually see what it is doing because it tells you step by step what it is doing. Any questions before I move on? Is it good? Okay. So what is AutoViz? AutoViz enables you to visualize any data set with a single line of code. It automatically selects a random sample from your data set if the data set is very large. So if you, let's say, have millions of rows or even billions of rows, as long as you can fit it into a pandas data frame, AutoViz will be able to visualize it. But you don't want to use all of the variables and all of the rows for visualization. You want a smaller data set or a smaller sample from your data. So AutoViz has an input argument or parameter which you can set that you can choose the number of rows, the number of samples that you want to visualize. You can set it anything from a few thousand rows to a few million rows. It doesn't matter. But this enables you to quickly visualize your data set. Second, you can also limit the number of variables that you want to see. You don't want to see hundreds of variables because it may take you a long time to go through them. You may want to see maybe 30 variables from your data set. Then AutoViz automatically selects the most important features, let's say 30 that you've asked for, and shows you only the charts related to that 30. All right. Next, it selects the best methods to visualize your data. Knowing what's in the data, which it automatically figures out, it selects the best charts to show you. And also you can save the charts in any format you choose. Okay, so why AutoViz? You want a way to systematically look at your data. It's simple and it's explainable. I'm not going to go much into the design goals. You can go through this yourself. But the main goals for AutoViz when I started to build it was to build it so that it's a single line of code. You select the most important features, you select the best charts and deliver them fast. How did I do it? One, I did variable classification, problem identification, and I figured out what were the most useful or interesting interactions. How do you install and run AutoViz? You do pip install AutoViz, and then you import the class called AutoViz class, and you initialize the class with an object, and then you call the object and its method called AutoViz with a data, like a data frame or a file name, and you can see your results almost immediately. So I'm going to go through this quickly. AutoViz has been downloaded about 17,000 times already. So you can see here the pip install AutoViz shows you that it is, sorry, that you can see here that it's been downloaded quite a few times. At the current rate, it's doing about 500 downloads a week. And here's how the plots from AutoViz look like. I'm going to actually show you this data set. It shows you a set of scatter plots, a set of pairwise scatter plots. So you will be able to see each numeric variable against a target. So in the Boston housing example, we're going to be able to see the room and the age variable. I have plotted against the median value of housing. So you can see that the room is highly, somewhat, non-linearly correlated to the median value, and same, the age of a house, as it goes towards 100 years of age, it starts to decline, but while it's 20 years or younger, it's got the highest values. And same way, if you see the pairwise scatter plot, you can see certain variables are highly correlated to each other. This is non-linearly correlated, and this is somewhat linearly correlated. You can also see all of the histograms of each variable, numeric variable. So the numeric variables are shown here. You can immediately see that this is somewhat right skewed, these two, and this is somewhat left skewed. And you might want to do something about that. You'll see the heat map of all continuous variables, which is, you'll see the correlation of each variable to the target variable, as well as you'll see the correlation between two variables each other. You'll see some bar plots as well. So after we know, how to do visualization automatically, we want to know how to build a better model. And there comes, VML. VML stands for a variant interpretable machine learning. You can call it VML or VIML or whatever you want, but I typically call it as VML, AutoViML. So you have a few steps that you need to do in any machine learning, whether you do it by hand or have an automated system do it for you. You want to remove low information and redundant features. You want to add some polynomial and interaction features. You want to select models from the simplest to the complex and perform some tuning. You might want some feature engineering, so how are the most important features selected? The features are selected using XGBoost. So we are not going to convert our features into something like PCA because those PCA features will not be very directly interpretable. Since my goal was to reduce features using the best features to a target variable, I'm using multiple iterations of XGBoost in order to select the most and the best features that are common to all of those iterations. Now, you add some features to the data. You can do some imbalanced sampling and training as well. So it handles imbalanced data set handling. And finally, you want to ensemble models, it'll do that for you as well. So how does AutoViML, how does it benefit you? It's systematic. It's designed from the ground up for a data scientist point of view. So you could approach any modeling problem from in a step-by-step. It also does automatic feature selection. Most of the times, AutoViML produces models with 10% to 99% fewer features than the regular model. So if you were to send a feature with, let's say, 5,000 variables, you will get a model with 50 features or 50 variables in the final model. How does AutoViML reduce features by 99% and yet produce a better model? Well, that's the magic or some of the secret sauce in AutoViML that you can go through the code and you can see how it does it. Multiple models, you can build and test multiple models from a single line of code. It's very transparent. It tells you how it does what it does. And I've given you the source code as well. So you can actually make changes to it if you don't like something. And feature engineering, it helps you add features selectively. I don't do a lot of feature engineering, but we do some feature engineering. Now I'm going to go through this quickly because I want to have half an hour for the demo. So we are about 3 minutes away from finishing the slide deck. So the AutoViML lets you try multiple approaches. I'm going to show you some of the inputs. The first input is whether you want to have interaction variables. So you want to add polynomial variables. Second is whether you want to do a boosting model or a bagging model. You want to do an ensembling or you want a stacking model. Do you want to do an imbalanced data set or a balanced data set? Do you want to do grid search or do you want to do randomized search? And do you want to see a feature importances the regular way or do you want to see it using SHAP? So it comes with SHAP, so you can also view it using SHAP. It's very simple to run AutoViML from your desktop. Just pip install AutoViML, and then you call the AutoViML method, and you run that method AutoViML, give it the train, your target variable, the test. The rest of it is all default. If you leave the defaults as they are, you will get a pretty good model. And then once you become comfortable, you can start to change each one of these parameters, and you will get different models for each one of the changes to the parameters. Now, AutoViML has now 50,000 downloads. It's currently running about 3,000 downloads a week. How does the results look? So for example, when we start with the linear model for the Boston housing data set, the data set size is about 506 samples or rows and 14 variables. AutoViML automatically reduces features by 24%. It takes 6 seconds to build a model, and the number of variables it selected was 10. So here's the top 10 variables. You're seeing about 5 plus 4, about 9 of those. And you can see that it gives you the RMSE, the mean absolute error, mean absolute percentage error, and then it shows you that these RMSEs as percentage of actuals. So you can tell whether this is a good model if the percentage of normalized RMSE is below 100% or closer towards 0. You typically want to see a model that's as close to 0 as possible with the errors, but it's not likely in the real world. Here are the results from the Boston housing data set. Here's the SHAP results from the Boston housing data set with the XGBoost. Wait, is that all there is? There's actually more. There's actually a lot more. You can build a linear model with interaction variables. You can build a random forest model with binned variables. You can build an ensemble model with binning. You can build an XGBoost model with stacking. So there's just no limit to not no limit. There are some limits, but there is a good way to do it. For example, there is a data set called the Wisconsin breast cancer data set. And when you run it through AutoViML, you get a 100% accuracy score. You might think, well, that's a very overfit model. But if you compare the results using a deep learning model, it's actually not overfitting much. And it actually produces better results than even deep learning models in some cases. Though not every data set you're going to get the same kind of results that you're seeing here, but it's really important to see how in a few seconds or even a minute, you're able to get a very good model thanks to AutoViML. And how did we get these kind of results? We reduced the data set size was 512 rows. The time taken was 12 seconds. We reduced features by 52%. So we didn't need that many features compared to the 32 features it had. And the average score was about 100 AUC. So what are the next steps? What's missing? No feature engineering, no image video NLP support, no time series modeling, though that's coming, no neural networks, and no model pipelines. What about AutoViz? What's missing in AutoViz? What's missing? It's not built into any other tools, so you'll have to build them yourself. It's not built into any educational tools like Excel, because it'll be nice to visualize data without writing any code. So I look forward to anyone who wants to take this to students or colleges, because it'll help visualize data without writing any code. And it'll be nice to add some visualizations like pie charts and mosaic charts. And if you can build this into industrial instruments like IoT, we don't have to have any code written to visualize any kind of data, because it will automatically generate charts if the data comes in. So these are some of the things. I finished the presentation in 32 minutes. Now we're going to go into the demo. Okay, so I'll pass the presentation over to Bill and you'll get it. Okay? All right, so how do we now, right? How do we now, I'm going to change this sharing. I'm going to share the, I'm going to share the entire screen. Okay. So the first thing that everyone should be aware of is the Git source for AutoViML. So I'm going to post it here. So if you were to click that GitHub link, you will come here. So I hope you can see my screen. So if you all click that GitHub link, and if you have a login, you can kind of log into your GitHub. So just sign in. And if you go to AutoViz or AutoViML, you can download the source code. What I would ask you to do if you are there is to just click the star. So if you click the star like this, you will get a chance to keep in touch with everything that I am doing. And if you were to click the watch button icon, you will be able to see all of the updates I'm making every time I make to the source code. So click the watch and the star. That way you'll be able to come back. If you want to fork the code, that's also very possible. This is for AutoViz. And in order to download the data, we are going to click this clone, and you're going to copy by clicking this button. So this will copy the code for the Git clone. Now we are going to go to my computer, and we are going to install or copy AutoViML and AutoViz to our desktop, right? So I hope you can all see my screen. In this screen, I have pasted Git clone, and then the this one that I copied, the link, you click enter. So just hit enter, and it will clone into your desktop AutoViz. Okay, so now that you have a copy of AutoViz, you can update it whenever you want, but that's something that we're not going to do because it's kind of, we have the latest version. Now we are going to go to the demo. So how do we run the demo? So in your directory where you have downloaded AutoViz, you will see an icon or a folder called AutoViz. If you go there, you will see a notebook called AutoViz demo. And this, if you click, you will get this screen. in your Jupyter notebook for AutoViz demo. Hope you can all see it. All right. If you can't, let me know. But here's the file name. So if you are following the data set, Boston CSV file is here. Sorry, where's that? Oh, there's another CSV file that's available on the web. Okay, that Boston CSV file, unfortunately, is so let it get it from GitHub. So yeah, let me get the GitHub link. Here's the GitHub link for the Boston data set. We are going to paste the file name for the Boston data set. So those who wonder where my GitHub is for the source code for AutoViML, it's here. Okay. All right. So we are going to run the first row. Now, if you have not installed AutoViML in your Jupyter notebook, you can also do this. You can do pip install AutoViz in one line into your Jupyter notebook, and it will install AutoViz for you. Got it? So if you have not installed it, that's the way to install it. Okay. So if you were to do pip install AutoViz, you will have this AutoViz class and everything. All you have to do is to next do this. I'm going to paste the code that you have to do. And once you paste the code, you are ready to, you will see an output that says AutoViz class has been imported. The version number should be 0.0.68. So if you have that, you can then copy and paste this code. So I'm going to just copy and paste it. Let me just make sure it runs. Okay, so it's not running. Error does not exist. The file username master CSV, Massachusetts, Boston CSV. There's the AutoViz demo. Here's the so here's the data set. Okay, so I'm now going to copy and paste your this data, so you can also follow along. So this works. You can see the 506 rows that it has. All right, and now we are going to feed this to so just say so the name of this is the target. Time. Sorry about my own computer. Okay, let me try it somewhere else on the other computer. So if you have the data set, you can download the data set, and I'm going to just show the downloaded data set to my computer. And if you were to run the code for AutoViz, it will run and it will show you, I've set the verbose to a high level, which is 1. And you will see the scatter plots of each of the variables. And it is now going to do a lot more, all the other scatter plots. It will take a few seconds. So you can see here on the screen how it has completed all of this, and it's still continuing. There are a lot more charts to come, all with a single line of code. So all you have to do is to point your AutoViz data set to your local machine. For some reason, it's not able to read it from that particular link. So I'm just posting this here. Now let's look at a demo of AutoViML. For this, I'm going to, again, take another data set that's a Boston data set. Okay, and if you do a pip install AutoViML, you should be able to run it. So that's for the next one, the demo. I already have it installed on my machine, but if you do that, you'll be able to install AutoViML. And then here's the data sets. Here's how you import. So once you have done your pip install, all you have to do is to call the AutoViML library. And here's the data set for Boston again. I have split it into train and test. And then now I have to just run it with the defaults as they are. I'm not changing anything. So it is building me a model. In this case, it's building a random forest model because it's here. I'm using a forest model. And it says it gives you an estimated training time. It's typically very fast. It'll be less than a minute for a few thousand rows. It'll be, depending on which machine you're running in Colab or something, it'll be a lot faster. On my machine, it tends to be a little slower. But you also have the ability to run cat boost. So I'm going to show you how to do that as soon as this is done. Any questions while we wait? Okay. All right. Well, we wait for that to go on. For some reason, my computer is acting up today. I want to show you something that that would be really helpful. You would how would output of AutoViML be used in production straight away? Your output of AutoViML can be the model itself is given to you. So For example, here it's taken about a minute to run. Unfortunately, I don't know why on my laptop. Typically, it should run less than a minute. You can see the best parameters for the model are given. It tells you what model, which is a random forest model, the number of estimators, the maximum depth, and the criterion that it used. It tells you, what the normalized RMSE, what the predicted versus actual looks. Here's the predicted, here's the actual. It tells you what the most important features are. It's taken fewer features to build this model. So there were how many features in this data set? It found only 8 features that was needed. It had 14 features. So it's very, it's very parsimonious in how it uses it. And you can see the results on a test set. I'm not able to see it here, but the results also can be seen. Now, let me show you an interesting way to use AutoViML in Kaggle competitions. Right? Here's the Kaggle data set. Right? So just click that link, and I'll show you how to use AutoViML in Kaggle. It works very well with very large data sets, and that's what I was going to show. So I've got a variable with very large data set. So let's take another data set that's very large. So let's go to the large data set with 900 variables, right? Because we really want to see, somebody wants to see how does it work on large data sets. So let's take a look at a data set where I have a sample here. I hope you all have a Kaggle account, because it will really work nicely if you have a Kaggle account, because I'm going to sign in. So once I've signed in, my Kaggle screen will look like this. I hope you can all sign in. And if you go to this link, again, I'm posting this link. Go to this link, all right, and sign in with your Kaggle ID, right? Once you sign in with your Kaggle ID, you should see your picture, your profile. You should see this notebook. You can click New Notebook. Click this button, New Notebook, and just select Create. Don't change anything. Python, Notebook, leave everything the same. Click this New Notebook. All right, so it will take a few seconds to prepare your notebook. So here's how your notebook looks, right? Your notebook, click the Run button, says Run. So you can click the blue button here, Run. You will see that I've already posted 2 data sets for free. So you can copy this second line for train. And then all you have to do is to write a small piece of code, says train pd.read CSV, and just read 1,000 rows, because this has got a very large number of rows. I think it's got hundreds of thousands of rows. Okay, so if you were to run this, you will see 900 variables and 1,000 rows. So I'm going to paste this code so you don't have to type it. So you can see that there are 900 variables. Now, pip install AutoViML into Kaggle. So next, install AutoViML in Kaggle notebooks. All right. Next, we are going to install AutoViML. It's now installed and it's now ready to go. Now, from AutoViML, you're gonna see import AutoViML. So do this, import AutoViML. So you got AutoViML ready. Copy this line of code, this blue in blue, and paste this in an empty cell in Kaggle notebook. So we are going to paste this in the next cell, empty cell. We have, what is the target variable in this data set? I already know the target variable in this data set, so I'm going to give it to you. The target variable is accuracy group. There is no test data right now. It's empty. That's it. You can run this. Let me make sure it runs. So you can run this with 900 variables, and it is going to start running in your Kaggle notebook. And it is saying that already that it has not found any missing values, but it has removed 400 variables out of the 899 predictors. And notice that it has now removed 62 variables in addition to that because they were highly correlated to each other. Among that, it again removed another 65, and it continues to keep removing. Finally, it has only 56 important features out of 900 variables. And it has done this in less than 30 seconds. And it has built you your model in less than a few seconds on Kaggle. And you can see here that the time taken for the entire thing was less than 1 minute. And you can now check your model by typing M. It's built a logistic regression model. Let's say M is the variable that I have given here for model. That's because I just like to type less. And if you want to know what features it is using, just type the word feats, because those are the names of the features it has used. So only it has used like 50 features out of 900. So if you want to change the model that it is running, just change the boosting flag here to cat boost. So let's say we want to run a cat boost model. Just rerun this again by changing the boosting flag to cat boost. So I'm going to, while it is running, I'm going to post here, run cat boost model by doing this. Got it? So if you run a cat boost model on 900 variables, even this will run for less than a minute. Right? So here we are. It's running. It's already got the cat boost results. It's ready. So here it is, built the model with the cat boost model, the balanced accuracy. Since we used only 1,000 rows, the model is not great because we only used 1,000 rows. But you can see that the ensembling model is doing much better with better balanced accuracy. And the time taken was less than a minute for the whole thing. So you can see how powerful AutoViML is on Kaggle notebooks. You can use GPUs, you can use CPUs, you can use higher RAM, and you'll be able to work on real Kaggle data sets in 1 minute or less. I hope this is helpful. Any questions? The time taken for the entire process was 1.3 minutes. Any Q&A, guys? So how can we use a model versioning tool like ModelDB? Every time you run a model with AutoViML, just save that model in model DB and give it a name, logistic regression with 56 variables. So if you do that, your model DB will have all these models saved in the database, and you will have the version control that you would need. I hope that's helpful. So the visualization for AutoViz is also very simple. Instead of doing pip install AutoViML, you just do pip install AutoViz, and you go from here. I've given you, like a super easy way to run AutoViML on hundreds of data sets in Kaggle without leaving Kaggle. So you can now compete in Kaggle competitions, old and new, with just a few lines of code. It tunes the hyperparameters in the model, and it shows the final parameters here. So you can see here that in selecting a model here, let me make this a lot bigger. So, where is this? So you can see that it has chosen the hyperparameters for the Cat Boost model. The learning rate is set to 0.07. The number of iterations was set to 36. So you can see for the Cat Boost model what the hyperparameters are. So right here, Cat Boost best parameters, iterations 36, learning rate 0.07. So 900 variables on 1,000 rows, but on 100,000 rows, it wouldn't take that much more time. I can do that if you want, 100,000 rows. So we're going to remove this line for 1,000 rows. Now I'm going to show you 100,000 rows. So 176,000 rows. We're going to use Cat Boost again. We don't have to change anything. We just have to run, and Cat Boost will start running. 176,000 rows. Sorry, 17,690 rows and 900 variables. Here, it's running right now. It's already removing, the number of variables. You don't have the ability to play with the hyperparameters yet. One day I might give you the way or a chance to play with your hyperparameters. It will fill the nans with a special code or a special value. So let's say you have a numeric data set. It'll fill it with a number like -999, as long as -999 is not in that data set. For categorical features, it'll fill it up with the word missing, as long as the word missing is not a value in your data set. If not, it'll find another word to put it. It will not remove any records. It will not fill it with mean values. So what kind of models are available? We have 4 models. It has about 14 to 20 different models that it uses for building